Stand on a beach long enough and you'll witness something strange and quietly enormous. The sea creeps higher and higher up the sand, then slowly retreats again. Do it twice a day, every day, all over the world, and entire harbors empty and refill. It's almost as if the whole ocean is breathing. But what could possibly lift and drop the entire sea like this? The answer is hanging in the sky. The main force behind the tides is the gravity of the moon. Even from 250,000 miles away, the moon constantly tugs on the Earth and on everything on it. The solid ground barely budges, but the oceans are free to move, so the water on the side of Earth facing the moon gets pulled toward it, heaping up into a gentle bulge. That bulge of water is a high tide. But here's the part that surprises almost everyone. At the very same moment, there's a second high tide on the complete opposite side of the Earth, the side facing away from the moon. How can that be? Because the moon doesn't just pull the water, it pulls the whole solid Earth too, tugging the planet away from the water on the far side. That water is, in effect, left behind, bulging outward into a second high tide. So our planet is wrapped in two bulges of water at once, one pointing toward the moon and one pointing directly away. Now, the Earth spins all the way around once a day. As it turns, your stretch of coastline sweeps through both of those bulges, one after the other. And that is exactly why most places on Earth experience two high tides and two low tides every single day. There's a subtle twist, though. While the Earth spins, the moon is also slowly orbiting around us. So by the time a coastline has rotated back to face the moon has moved on a little. The Earth has to turn just a bit further to catch up. That's why the tides don't arrive at the same time each day, but creep about 50 minutes later with each passing day. And the moon isn't working alone. Our sun is unimaginably more massive than the moon, and its gravity pulls on the oceans as well. But because the sun is so staggeringly far away, its tide-raising effect is actually a bit weaker than the moon's. Still, it's strong enough to matter, and the interplay between the two is what gives the tides their changing rhythm. When the sun, the moon, and the Earth all line up in a row around the full moon and the new moon, their gravitational pulls combine and reinforce each other. The two bulges grow, and we get especially dramatic tides, very high highs and very low lows. These are called spring tides, a name that has nothing to do with the season, but with the water springing up. When the moon and the sun sit at right angles to each other, as they do at the half moon, their pulls work against one another. The sun's tug partly cancels the moon's, flattening the bulges. The result is the gentlest tides of all, with much smaller differences between high and low. These calmer tides are known as neap tides. Geography matters too. The shape of a coastline or a narrowing bay can funnel and amplify the water, turning an ordinary tide into a giant. In Canada's Bay of Fundy, the sea routinely rises and falls by over 15 meters, taller than a 3-story building. The same cosmic pull, shaped by the land, can be gentle in one place and staggering in another. So the tides are nothing less than the visible heartbeat of a cosmic tug-of-war, the moon and the sun pulling on our oceans as the Earth spins beneath them. Every rising tide is a reminder that we're connected to worlds far beyond our own. The next time the sea climbs up the shore, you'll know it's the moon, reaching across space to gently lift the ocean. And if there's a science or space topic you want explored next, tell me in the comments. Your question could be the next video. If this made you a little more curious about the world, subscribe to the Binary Brew, and I'll see you in the next one.